Hello everyone, Tom from everystepphysics.com, everystepcalculus.com. A problem in physics dealing with springs, and they give work at the beginning and you figure out the spring constant and then do work calculations given different stretches in the problem. Let's do it. Physics to get to my main menu. And I'm going to scroll up to get quicker to, that goes to the bottom of the menu, and you can scroll up to get to the S's. S's are a little bit closer to the bottom than the A's. So we're going to go to springs, choose that. And it's a horizontal, make sure you know that. Spring is either vertical or horizontal. If it's vertical, you're always dealing with, in the calculation, with gravity, of course. In a horizontal spring, you're not dealing with gravity unless it's they give you the coefficient of kinetic friction, or a friction force is involved. So we're going to choose that, and the problem gives us work, and then the stretches of x1 and x2. Choose that. Finds the spring constant from the work formula using stretch x1, okay, and finds work over different stretches that are given as the spring moves from those points to the equilibrium. You have to press alpha before you enter anything in these entry lines here. And it's given alpha 2. Whoops. And the first stretch is given as alpha 3. Centimeters. They do the calculations for you. That's important. Look out for those tricks in physics. Physics is difficult enough, and then they trick you with different things, or, you know, try to make you really critically think. And all we want to do is, you know, learn enough about physics to pass the test and get out of there, never to touch it again. Same thing with calculus. The second displacement is given as alpha 5. Centimeters again. I always show you what you've entered. You can change it if you want. I say it's okay. I'm going to choose number 1. And so you use the work formula and find, because they gave you that, and with algebra you switch this stuff around and you get the spring constant here, 44444 newtons per meters. And then we're going to do the displacement, the net displacement, which is you stretch the spring 3 centimeters, 0.0 meters, 0.03 meters, and then you stretched it 5 centimeters more. That equals 8 centimeters as the spring goes back to equilibrium, the way I read the problem. And so the work, when you do it with the work formula here, at 14. Now we can use another stretch, because they give you different stretches, and the next one we say yes, and the next one they give you is 7 centimeters, alpha 7. Again, centimeters, changes it to meters. Say it's okay. Spring constant again, and then the x net is 0.1 meters. And the work is 22 joules. The next stretch they give you is 3. Alpha 3 centimeters. Say it's okay. It's a net movement of 6 centimeters, or 0.06 meters, and that works out to be 8 joules for work, etc. Another stretch was -1 alpha minus 1 centimeters. There's the net movement equals that work. And one more, they give it as alpha minus 7 centimeters. I say it's okay. There's 3 it's stretched already, and then you're going to unstretch it by 3 and then keep going to 7 meters, which is really a net movement of 4 centimeters. Say it's okay. There's the minus 4 centimeters, and equals this amount of work. Pretty neat, huh? everystep.physics.com. I don't know how you can pass a physics test without these programs, given your other classes and stuff, so think about that as you decide maybe to buy my programs or not. Hey, have a good one. I'm all for you passing physics and calculus.